What is the value of work done for rotating a coil by 180 degree against the torque? Whereas the value of width and length and the current and a magnetic field is given in the question. It's known that the work done in rotating a coil can be calculated using a formula W is equal mv cos theta 1 minus cos theta 2, whereas m is representing the value of magnetic dipole moment, but there is no magnetic dipole moment is given in the question. It's known that the magnetic dipole moment can be calculated using a formula NIA, whereas N is representing the number of turns which is given as 250, whereas I is representing the current value which is given as 85 microampere, which means 85 times 10 to the power negative 6 ampere. Whereas A is representing the area. There is no detail about the area in the question, but there is a detail about the shape which is given as rectangular coil, and there is a detail about the length and width. So the area of rectangle is nothing but length times width. So here we can write 2.1 times 10 to the power negative 2 times 1.25 times 10 to the power negative 2, because both values are in centimeter. Whereas B is representing the value of magnetic field strength, which is given as 0.85 Tesla. Whereas theta 1 and theta 2 is representing the angle value. It's given in the question. It was rotated for 180 degree, which means theta 1 will be 0 and theta 2 will be 180 degree. So let us apply the values here. So let us apply the values here. Work done will be equal to N can be written as NIA, V, and the cos theta 1 will be 0 degree minus cos 180 degree. So when we are solving this, we will get 2 for this value times N I A times P. Now we can apply all the values. So it can be changed as 2 times 250 times 85 times 10 to the power negative 6 times 2.1 times 10 to the power negative 2 times 1.25 times 10 to the power negative 2 times the value of V, which is given as 0.85. When we are simplifying this, we will get the answer of 9.4 times 10 to the power negative 6, and the unit will be joule. So it can be written as 9.4 microjoule, right? So the correct answer for this question is option D here.